4, pages 73 to 80, Properties of Aqueous Solutions. Properties of aqueous solutions. When a small amount of chemical material is dissolved in a pure liquid, the solvent is the majority material and the solute is the minority species. Water is usually the solvent and some sort of salt is usually the solute. The entire mixture is called the solution. So when we say a solution, we're referring to a mixture that contains both a solute and a solvent. And then your solute is going to be the particles that we represent, and we don't usually represent the solvent, which is the water molecules within the liquid. When ionic compounds are dissolved in water, the ions separate and become surrounded by the water molecules. Here are some typical ways in which ionic salts dissolve in water. So here's sodium chloride as a solid. When you put it in water, it's going to break up into its cation, sodium +1, and its anion, chloride -1. Notice that they are aqueous afterwards because that means they are in a water solution. Magnesium bromide, you're going to get one magnesium ion, which has a +2 charge, and because of the subscript of 2, you're going to get 2 coefficient bromide ions. And then here, because that has a subscript of 2, you're going to get 2 coefficient of potassium ions and 1 sulfide ion with a -2 charge. So let's look at this diagram. We have potassium sulfide, which is going to give us 2 potassium +1 ions and 1 sulfide ion. When they separate, you're going to have potassium being positive is going to become surrounded by the partially negative oxygen atoms in the water molecules, as opposed to the sulfide, which is negative, is going to become surrounded by the partially positive hydrogen ions or hydrogens in the water molecules. In water, the solid K2S crystal comes apart into ions. The ions separate from each other. Each ion, cation and anion, is surrounded by a sphere of water molecules called a hydration sphere. Ions carry charge, so their movement through the solution allows the solution to conduct electricity. Since all of the K2S breaks apart into ions that carry charge, potassium sulfide is called a strong electrolyte. Because you get 100% ions, it's a strong electrolyte. The symbol S2- aqueous refers to separate sulfide ions surrounded by a sphere of water molecules. The symbol K2S aqueous implies that the potassium positive and sulfide negative ions have separated from one another. Molecular compounds made up of non-metal elements do not break up into separate ions when they dissolve in water. So here you're looking at molecules that are completely intact, but they are just separated from each other within the water. So they're in the water, they could be dissolved, but they don't separate into any ions. Here are some examples of molecular compounds that do not make ions when they dissolve in water. Sugar, methanol, ethyl alcohol. Recall that molecules that are molecular compounds do not contain charged ions. When these compounds dissolve in water, the compound remains intact in an uncharged form. No ions are formed when the compound dissolves. Acids and bases. Some acids and bases are molecular compounds that do make ions in water. In general, acids donate a hydrogen with a positive charge and bases accept a hydrogen with a positive charge. So for example here, hydrochloric acid is a strong acid, which is going to do what's called ionize 100%. And so it will give us an H+ and a Cl-. Here is ammonia, and when you place it in water, it's going to be a base where it accepts a hydrogen from the water and forms into ammonium ions and hydroxide ions. However, this is a weak base, which only partially turns into ions, which is represented by the equilibrium symbol in the middle, meaning we have both the forward and reverse reactions occurring, as opposed to this arrow here, which states that it goes completely to these products. You're going to want to memorize this list of strong acids. Make sure you know the formula and the name. Hydrochloric acid, hydrobromic, hydroiodic. This is chloric, perchloric, nitric, and sulfuric. And then these are weak acids, but you don't have to memorize these. If it's not one of the 7 strong, then it's going to be automatically a weak acid. These are the strong bases, and you should also memorize the strong bases. Anything that's not one of these strong bases is automatically a weak base. An acid or base not listed as a strong acid or base would be considered a weak acid or base. Note, ammonia is a molecular compound that is an exception. It partially makes ions in solution because it is a weak base. So we would see NH3 and believe that that is a molecular compound and therefore a non-electrolyte, but it's actually a weak electrolyte because it's a weak base. Strong and weak acids and bases. Most acids are molecular compounds that create ions when in water. Strong acids and bases completely dissociate into ions. So this forward arrow shows a complete change from this to these. Weak acids and bases only partially dissociate into ions. Under typical conditions, many weak acids have less than a 1% dissociation. Common strong acids are listed in the table in the margin. To identify the strength of an unknown acid, such as formic acid, HCHO2, look up the acid in the table of strong acids. Since it's not in the table of strong acids, then you should go ahead and assume that it's going to be weak. So this would actually be a two-way arrow because you only partially dissociate 6% into these, while 94% remains this. Strong, weak, and non-electrolytes. Materials are classified as strong, weak, or non-electrolyte depending on the electrical conductance of a solution of the compound in water. The electrical current is carried by the charged ions in the solution. In general, the more ions a solution contains, the higher the electrical conductance. So here, because you have all molecular molecules here, there are no ions. You know this because you see no positive or negative charges on them. So you can assume these are molecules that do not form into ions. They just remain intact and they're floating around. So this is not going to conduct any electricity because there are no ions, so it's a non-electrolyte. This is going to be generally molecular compounds. These are going to be two or more non-metals that are combined with one another. Strong electrolytes are going to conduct electricity strongly, and these are going to be ionic compounds, strong acids, and strong bases. They form 100% ions. Everything in here has either a positive charge or a negative charge to imply it is a strong electrolyte because it has many ions. A weak electrolyte is going to conduct electricity weakly, and it's because it only partially turns into ions. So you see, mostly we have the original molecules that are intact that do not have any charges, and then you have a partial, like a small percentage that did go ahead and turn into ions. So since there are a few ions, it's a weak electrolyte. This is going to be weak acids and weak bases. Non-electrolytes are typically molecular compounds whose solution does not conduct electricity well. The compound dissolves in water but does not create ions necessary to carry the charge. Examples are sugar, methanol, and ethyl alcohol. Strong electrolyte are ionic compounds that fully dissolve and completely ionize are strong electrolytes because they produce ions that carry a charge. Examples are salts like sodium chloride, strong acids like hydrochloric acid, and strong bases like sodium hydroxide. Weak electrolytes are ionic materials that are highly soluble but only partially ionized. Are weak electrolytes. Weak acids like formic acid, hydrofluoric acid, and weak bases like ammonia are examples of weak electrolytes. Only a small percent actually dissociate in ions, making a solution with a low concentration of ions that is poorly conducting. Again, the material can be highly soluble, however, only a small percent ionize. So here's example 4.26. Determine whether the following materials will be strong, weak, or non-electrolytes when dissolved in water. So potassium chloride, because this is a metal and a non-metal, it's ionic, and since it's ionic, it's automatically a strong electrolyte. We have hydrochloric acid, and because it starts with hydrogen, so that makes it an acid, the question is it one of the 7 strong? And it is one of the 7 strong, therefore it's a strong electrolyte as well. We have HF, which is hydrofluoric acid. It starts with hydrogen, so you know it's an acid. The question is it one of the 7 strong? And if you look at the list, it's not. So it's automatically going to be a weak acid, which makes it a weak electrolyte. Then we have KOH. And because it has hydroxide, you know that this is a base. And because this is a group 1 metal, then you know that this is a strong base. Therefore, this is a strong electrolyte. Then we're going to look at CO2. And because this is a non-metal plus more non-metals, everything here is a non-metal and it's not an acid or a base, then automatically this is going to be a non-electrolyte. Here's a little map that might help you. The question is first, is it an acid or a base? Yes, if it's an acid or base, then is it a weak or strong acid or base? If it's weak, it's a weak electrolyte, and if it's strong, it's a strong electrolyte. If it's not an acid or a base, is it ionic? And you know if it's ionic if it has a metal. or ammonium, which is a polyatomic ion. If you do have an ionic compound, then yes, it's strong, and if you don't, then no, it's a non-electrolyte automatically because it's a molecular compound. So the way to do this problem is to determine if ions are made when the material dissolves. If so, is the concentration of the ions large or small? Then refer to the diagram. Most of the time, the following flowchart will work. Now you can pause the video. Here's your note card for this section. If you have a strong electrolyte, then it's going to be an ionic compound, a strong acid, and a strong base. If it's a weak electrolyte, it's a weak acid or weak base, and a non-electrolyte is going to be a molecular compound. The 7 strong acids are here, and if you have an aqueous solution, understand that it's going to dissolve into its ions, and if it's a positive ion, it'll be surrounded by the oxygen or the partial negative part of the water molecule, and if it's a negative ion, it'll be surrounded by the hydrogens or the partial positive charge of the molecule.